In this video, we're going to continue our discussion of NeoPixels and kind of rehash a little bit of what we talked about in functions to create these different animation functions that we can copy across various projects to do some really neat things with our NeoPixel. So let's go back to the code we were working in here, where we kind of had it going from the end to the beginning and setting each color to be a random pixel. And actually what I'm going to do is I'm going to back up this code. I'm just going to hit Control Z to get back to this state here, where we were going from the beginning to the end and setting it to each be these different R, G, and B values. And so what I'm going to do is I'm going to create a function that implements this same functionality so that I don't have to copy and paste this code a bunch of different times. I can just call this function anytime I want it to happen. And so what we need to do is we need to declare our own function. It's going to be outside of setup and loop. And the first step that we do is we define the header, which defines the interface between what is calling the function and the function itself. It kind of describes what inputs and outputs are going on. And so for our function, we're going to just call it color wipe because that's kind of what it's doing. We need to define if there are inputs and if there are outputs. And so as far as outputs, there's not going to be outputs in terms of like a value that is returned back. There is going to be an output that is like updating the NeoPixel strand. That's kind of what's known as a side effect because it's not actually returning anything, so there's no real output value, but it does have some side effect. The side effect is that it changes what's happening on our NeoPixel strand. And so what I'm going to do here is I'm just going to describe this as void, meaning that there are no return values. But then we need to think about, okay, are there inputs that we need to provide to the color wipe function in order for it to do its job? And yeah, we need to tell it what color we want it to be, but we also maybe need to tell it like how long we want this animation to last. And so what I'm going to do is I'm going to define, I think, 4 different values that are going to go inside of here. They're going to be the red, green, and blue colors, as well as like the time between it updating one pixel and the next pixel on down the line. And so when we are defining a function header, we need to declare each one of the little variables inside of there that are parameters that we're going to accept some values and use those variables inside of here. So I'm going to call this int R, int green, int blue, and then we'll call the last one wait, which is just our delay here. And so now what I could do is I could copy this and essentially just put it inside of here without having to change a whole lot. So it's still looking for some R, G, and B variables, but those are defined here in this function header. These are the parameters that are being passed into here. All right, and so I is still being defined here by this for loop, and then we have this new variable wait, and so what I'm going to do is I'm going to put wait right there. And now what I can do is I can just get rid of all this stuff inside of loop. And if I want it to do a color wipe, what I can do is I can say call color wipe and pass it those 4 values. It even starts to autofill it here for me, or just kind of indicate what it's expecting. So if I wanted to just do red, I could say 255.00 and then tell it to wait. And then let's maybe also have it do a, I don't know, like a purpley color. So we'll say that, and then I'll tell it to wait a little bit longer. And so what should happen is it should do the same thing, but we're kind of breaking it down into these chunks. That's what a function is good for. It's good for like defining some task that we want it to do, and then once we kind of defined how it works and what values it needs, we can then call it anywhere in our program and use it. And then we can also copy and paste this function into any of our different projects that use the NeoPixel where we want to do this functionality, where we want to do this animation, and then just call it. So once we've broken it down into a function, it's really portable and easy to use in a variety of different contexts. So let's see if it does this red. There's a red, and then there's our purple going a little bit slower, and then the red goes fast, and then the purple goes slower. So our color wipe function is working. So let's go back here, and we can say, all right, let's do another one. We kind of did this in the last video. We reverse the direction. So let's create another one called color wipe reverse, where now what we're going to do is just change this part of the for loop so that it goes back to front instead of front to back. And so that involves us saying strip.number of pixels -1, and then this should be while I is greater than or equal to 0, and then this should be minus. And so now what I can do is I'm just going to copy and paste this because, you know, work smarter, not harder. I'll say reverse and reverse. So it's going to do red, purple, and then reverse red, and then reverse purple. So let's see if we had any errors. It's looking good. It's looking good. Let's go back to the camera. So it goes red forwards, purple forwards, and then it goes red in this direction, and then purple in this direction. So there, we just built two functions that, you know, perform specific animations, but, you know, we left enough open-ended that we can change things like the color or how long we want it to wait, and we can use this across a variety of different projects just by copying and pasting this code. So let's do a couple more before we close out here. So let's see. Let's do like one where we set like a random pixel to be some color, right? So let's just say random pixel, and again we're gonna have it accept some values here. We'll say int green, int blue, and we don't need any sort of delay on this, but we can just say choose a random pixel over which we want it to show that. And so what we can do is we'll say strip.set pixel color, and the first value that it wants is which pixel we want. So we can use random for it to choose which one. So we'll say start it at 0 and go up to strip.num pixels. And then we'll tell it the color we want it to set that, which is just going to be RGB. So that's actually all we need for that. So it might seem weird to write a whole function just for one single line of code, but you know, I think it works for us. So let's try to call this and see what happens. We can maybe add a delay so there's a little bit more to it. So let's say like wait half a second. All right, so random pixel, and let's see, we want it to be, let's just have it do something a little bit different. So let's do like a teal color. We'll do 127, 127, and that's all we need for that. So I'm going to copy and paste this a few times so we can see a few of those teals show up. And let's send that over to there, and it's coming up. So our purple's going back around, red. Oh, we did forget something. So, oh, it's also complaining. Number of pixels returns, All right, we had some errors here. So we need parentheses after this. And the other thing that I forgot to do is we have to do strip.show if we want it to show those changes. So now let's try it and let's see if it works here for us. All right, it's going through, it's going through. There we go, so it randomly set some to be teal. Yeah, so that looks good. All right, so let's maybe think about one other one we could do. Let's do a single color or a single pixel that is a specific color that kind of falls down the strand here. All right, so it's going to be similar to our color wipe, but what we need to do is we need to have it update one at a time, but we also need it to clear out the other ones there so that they're not being shown. So let's see if we can get that to work. So I'm going to start with color wipe as my starting point here. And I'm going to say, we'll just call it, oh, somehow I got all caps on. We'll just call it falling pixel. And it's going to have all of the same parameters, and it's going to go through each one of these. But let's have it do strip.clear first. And let's see if that's like sufficient to make this kind of work for us. oh, I need my semicolon. And now we're gonna, well, we'll check for an error just by hitting upload. But then I also need to call it up here. So I'm gonna comment this out just so we can get right to testing this. So I will say, let's do, just copy and pasting these, and what I'll do is I'll change this to be falling pixel instead. And let's upload and let's see what we got. Yeah, that seems like it works a little bit. I think if I were to delay, we would see maybe some little behavior that we don't necessarily want. Oh, what happened there? Delay 1000. All right, so let me upload this. My suspicion is that the last LED stays on. So yeah, so when we delay at the end, we see that it's actually the next one that keeps that pixel. It keeps that last pixel on until it gets to the next falling pixel, which clears them all off. And so what we could do to kind of make sure that that last one turns off after that delay is we can go back here, and here it is. So after this, we can say strip.clear and strip.show to make sure that that last one does indeed turn off before it gets to the next animation, because we want the next animation to kind of start with a clean slate. And so let's make sure that it works. Yeah, that red one's off, and they're all off for that 1 second delay until it goes to the purple. So there's our kind of falling pixel animation. And so let's just tie it all back together here. I'm going to get rid of that and bring all these back in, and we can see all of our animations kind of run in unison here. And yeah, that's the really nice thing about these functions, is now that we've built them, we don't have to think about it, right? We can just call it anytime we want it to happen and copy it across these various projects.